So before we move on to talk about the Node Package Manager, I wanted to spend a couple videos doing some really straightforward Node application samples. And the reason I want to do this is even for people who aren't interested in using Node to write applications with, people who might just want to use Gulp or what have you in the context of another platform, you really need to understand kind of how Node likes to do things. And there's a couple really important topics that I want to cover. So I figured the best way to do it would be to put together a couple example applications and then just talk about the different common patterns and practices that you'll see come up as you will write Node applications. So what I have here is an empty folder. And what I'm going to do is I'm just going to open up code. So I'm just going to do code./ and it opened up on the other monitor because of course it did. And I'm going to go ahead and set up this really quick example. Basically, all it's going to do is it's going to read all the files in a directory and print them out to the screen. Now, this is going to give us a great opportunity to talk about asynchronicity as well as how Node likes to deal with callbacks and all that fun stuff. So it's a really quick, simple example, and I guess let's go ahead and get started. I'm going to start by coming up here and create a new file, and I'm going to name that file index.js. And then inside index.js, we're going to require in two other modules. And what's going to be interesting about these modules is they're built into Node itself. The first module that I'm going to include in is going to be fs. So I'm going to say var fs equals require fs. And then the second module I'm going to include is path. So require path. Now these are going to be two very, very common modules you're going to be working with, and there's a couple things I want to point out here. First of all, these are built-in Node modules. They are not relative to our current working directory. As you see, there's no // here on path. It's just Node knows about the path module and is going to allow us to require it in directly. And so as far as the naming here, it's very common when we're including in these kind of packages to name these variables fs and path. As you saw in the last video when we talked about common.js, the names of these variables that I'm using is completely up to you. It's completely irrelevant. But I would ask that when doing things like fs and path, you use the words fs and path, because then other Node developers, it's a very common convention that other Node developers will pick up on. Now, fs stands for the file system. This is going to be the package that we use for accessing the file system, reading directories, creating directories, all that fun stuff. In fact, you can read about all the different things that the fs package can do by hopping over to the documentation. And I know I'm bringing up documentation a lot in this series, and there's a reason for that, is I can't cover everything, and the documentation is actually really good. So if you want to know anything about working with the file system in Node, definitely check this out. But at the very least, I'm going to show you guys basically how to work generally with this package, because it's a very important package. So the other module that I'm using is path, and path is just a module package, whatever, that deals with, well, paths. You can do things like convert from absolute to relative paths, you can join paths, all that fun stuff. It's cross-platform, works on macOS and Linux and Windows, so you don't have to worry about different path delineators. But anyway, so we have fs and path imported. So before I actually write the next bit of code, I want to go ahead and create the folder that we're going to be working with in this example. Because like I said, I want to read all the files out of this folder, and then I want to print out their contents to the console. So over here in my Solution Explorer, or whatever you call it in code, I'm going to click the New Folder button. So inside the new folder little text box there, I'm going to say Documents. So we're creating a folder called Documents. Then I'm going to right-click Documents and create a new file. And let's do document1.txt. And let's just put some arbitrary text in here. So I'll say this is document1, hello world, stuff and things. And then really quickly over here, I'm going to select document1, hit Control-C, Control-V, and create another document, in this case document2. Code will automatically change the increment the last number when you copy and paste in the same directory. Then I'll say this is document 2, and maybe add some more lines, in this case just some gibberish. And let's just do one more. Control-C, Control-V, change the top line to document 3, so when it prints out we know what document we're working with. And then I'll change it to this is also last document, or something like that. Doesn't really matter. Okay, so we have our documents folder, and it has 3 documents inside of it. Document 1, 2, 3. These can be anything you want. They can be text files, JavaScript files, whatever. It's not important for this example what they are in particular. So now what we want to do is we want to read in all of these files. We want to get a list of all the file names that is inside the documents folder. Now before we do that, I am going to go ahead and just alias out the name of that folder. So I'm going to say var directory equals document. So I'm doing this so that, or let's do /documents. I'm doing this so that, because we're going to need to reference this directory more than once, I would rather it be out in a variable up here. So another question is, how do we use the FS module? Now, generally the FS module, all the methods in it come in two flavors, the synchronous methods and the asynchronous methods. Now, we haven't yet talked about the concept of asynchronicity. Now, the concept of asynchronicity is basically that for long-running operations, such as accessing the file system, I mean, accessing the file system compared to accessing memory it is ridiculously more expensive, and it takes a very long time. And while we're accessing the file system, the CPU really isn't doing anything. It's not processing instructions or performing any logic, because all of that behavior is offloaded to a different piece of hardware while we're waiting on the the hard drive to spin up or it to position its internals in order to access the data. So, and the same thing could be said for network access. So network access takes a while. It takes a while to download stuff. Your CPU isn't doing anything. So why would you start a long-running operation and have your CPU just kind of sitting there blocking the thread, not doing anything important, when it could be going off and doing another thing? And that brings us into another thing about Node that's incredibly important to understand. And this actually applies to JavaScript as a whole. JavaScript is a single-threaded environment, meaning you'll never have two threads doing something simultaneously at the same time. The only exception to this is the web workers, which is something that it's a modern API that allows us to actually do threaded stuff, but working with web workers is a little bit beyond what we're talking about here. Basically, the runtime is single-threaded. So what that means is while Node is processing a request, you might have heard that Node is has such high throughput and is able to process so many requests simultaneously. Well, the reason for that isn't necessarily that JavaScript is a particularly quick language. The main reason for that is Node is built around the concept of asynchronicity. It's built around just generally that you tell a long-running operation to go do a thing, and then when that thing is done, it informs Node, okay, the thing is done, now we can process the rest of the code. But in the meantime, Node is processing other requests or other whatevers while that's happening, and that's really cool. So FS provides most of its methods in a synchronous and asynchronous context. And so we're going to look at both of those. The first one is going to be the asynchronous one, because you'll generally be wanting to write asynchronous code by default for the reasons I mentioned just now. So the method we're going to be looking at is fs.readdir. So I'm going to say fs.readdir directory. And so, like I said, this is an asynchronous method. So it technically has two parameters, but let's just say it has one parameter. It has one parameter, which is the directory it's going to list the files from. Now, the second parameter is going to be a common thing that you're going to see on pretty much every single asynchronous method invocation, and that's going to be a callback function. So what we're going to do is we're going to enter in a anonymous function here, and the anonymous function that we're going to pass into readdir is going to accept two parameters, ERR and files. So let's talk really quickly about this. This is a common convention in Node for how to deal with asynchronicity. The callback will always be the last parameter of an asynchronous method, and the callback will accept an error parameter and then followed by the other parameters that might be returned by the operation, in this case, the list of file names in the directory. Now, if error is non-null, if it's defined, what that means is that, well, there was an error, something broke, and it's notifying us that there was an issue. So the most common pattern here is, when working with the synchronous node functions, is to go ahead and the first line of code inside your callback would be something like if error, console.error, error, and then return. So we're immediately exiting out of this asynchronous closure in the case that there was an error after printing that error out to the console. So it's really important to not forget that, because you're not going to get exceptions thrown with asynchronous code, because where would the exception be thrown to? So you're always going to want to check for the error parameter. So the next thing we're going to do is let's go ahead and loop through all the files. So I'm going to say for var I equals 0, I smaller than files.length. So files is an array of strings. I++, and then I'm going to say var file equals files at I. And let's just go ahead and console log out the file for debugging purposes. And let's actually just leave it at that. I think this is a good starting point. So coming back over here to our console window, I'm going to go ahead and hit node dot to execute the default index.js file. And hit enter, and we see document 1, 2, and 3 have been printed out to the screen. So now we know that fs.readdir is properly reading that directory. So that's really cool. Interesting side note. Again, the whole point of this video is just to point out things as I think of them. The interesting side note here is you might be wondering, okay, so fs.readdir is asynchronous, and I can prove that by saying console log start and then console log end, and then running node again, and we see that start and end are printed out before our callback is invoked. That's because fs.readdir immediately returns back into our execution of index.js before it gets around to actually printing out the files or calling our callback. So what's interesting to note is you might be wondering, how does Node handle not closing out the application when it hits the end of the script? Because that's generally how you would think of JavaScript. JavaScript hits the end of the script, it stops, so then it doesn't, but clearly it's not exiting the program until the fs.readdir is finished. Well, just bear in mind that when you start an asynchronous operation like this, it will complete before Node kills the process. So this is a very important thing to keep in mind, that you can start an asynchronous process, but even if it hits the end of the script, it'll still be running the application until all of those asynchronous processes are finished with. So if I were to launch an asynchronous process within this callback, that process would be finished before the program exits. Anyway, so now let's look at an example of how to use the synchronous methods of FS. So like I said, FS provides asynchronous and synchronous methods for most of its stuff. Now the asynchronous ones are typically the ones that are just the straight up name. And so in this case, readdir is the name of the function. But there's another function that we want to use here. It's going to be called readFile. And readFile is going to return to us a buffer, an object that represents a the text of the document, when we tell it or ask it or tell it which file that we want to open up from. That my words might have gotten away from me a little bit there. fs.readFile is responsible for reading a file. There you go. And we want to do this synchronously because I want to show you guys an asynchronous example. So I'm going to say var file contents buffer equals fs.readFile sync. So sync is appended to the corresponding methods that are going to execute synchronously. And so readFile is a valid method, but it will be like readdir, it'll accept a callback. ReadFile sync, however, will run synchronously, meaning this code is going to block the execution of all JavaScript code running on this node process until the file system module is finished reading the contents of this document. Now, obviously, this isn't what you would want in a lot of circumstances, and I don't recommend it, but in some circumstances, especially if you're writing a simple script to do something just straightforward and you don't really care about server throughput, it can be very useful, but in a larger scale application, in a web application, you would stay away from the synchronous methods as much as possible. But they are super convenient because you don't have to add in the callback stuff. Furthermore, if an error happens during readFile sync, an exception will be thrown right here, and it'll stop execution, so we don't have to add the if error, console error code like up there. So readFile sync, not surprisingly, is going to accept a single parameter, which is going to be the file that we want to read. So to do this, I could say directory plus file. I could do that. And I could also use string templating, which we'll talk about when we talk about ES6 features. But I don't want to. Generally speaking, it's considered much better practice to use the path module to do things such as combining paths. So in this case, it's going to be path.join. So again, path is the module that we imported here on line 2. And path.line_join is going to accept a list of paths, and it's going to join them using whatever delineator is used on our current environment, be it a backslash on Windows or a / on Unix systems. So I'm going to do path.join directory, file. Now let's go ahead and print out the file contents. So I'm going to say console.log. Now I can't do file contents buffer because this is a buffer object. If you want to learn more about buffers, you can head over to the documentation. It's not going to be a big concern for us until we get to talking about Gulp. But know that this is an actual object that represents the file contents. In order to convert this buffer into a textual representation, so we actually can see the contents, we're going to have to use the .toString method, not surprisingly. And that's it. Let's node this up and check that out. So we have all of the files in this directory being enumerated, and we have their contents being printed out. So I think that's pretty cool. So again, this is a quick little example. That's about all I wanted to do here, and it gave us an opportunity to talk a lot about about some really important nodeisms that you're going to have to be aware of. Generally, always prefer asynchronous code unless you're writing a script. FS is for file system, path is for path, and documentation is good. But I think that's all I wanted to do in this video. So in the next video, we're going to do something similar, but I want to throw together an actual Node application using an actual HTTP server. That'll give us the opportunity to talk about a couple other interesting things. So we'll see you then.